2 and 3, we're asked to write the functions that represent the piecewise functions that are given here. So let's start. For number 2, we're going to set it up, f of x equals, and we're going to have two pieces of our function. I'm going to split the graph just so that to help us determine our x values. Notice that I colored in the y-axis, which is the line x equals 0. Therefore, the graph on the left is represented by the domain values x less than 0. The graph, or the piece of the graph on the right, is represented by the domain values x greater than 0. And actually, because the endpoint is closed, we're going to say greater than or equal to 0. Now, these are our two domains. In order to find the range part of our functions, or the equations for each of these pieces, since they are linear, we are going to find m and b and write a linear equation using m and b. Okay? For b, for this first part, b is our y-intercept, and this graph touches the y-axis at 3, although it is open there. And our slope, using any 2 points on this portion of the line and working left to right, we would go down 1 and over 1. So our slope, or rise over run, is negative 1 over 1, or negative 1. If we put m and b into our equation, we get the equation y equals negative x plus 3. Y equals negative x plus 3. To do the right-hand equation, again, we need to find m and b and write an equation. Our b, or y-intercept, for this part of the line is at 1. Our slope, using any 2 points, since the slope is constant on a line, and going left to right, we get up 1 over 1, or a slope of positive 1. Plugging those into y equals mx plus b, we get the equation y equals x plus 1. And our piecewise function is complete. Now we need to do the same thing for number 3. Again, let's set up the structure of the function, noticing that this one has one linear piece on the left and one stepwise portion on the right. Again, just looking at the domain values, this is the line x equals 1. Therefore, the portion on the left, or the linear function on the left, will be represented by the domain values x less than 1. In order to find the equation for this portion of the function, just as we did in number 2, we will identify m and b. M, in this case, b, in this case, we cross the y-axis at 2. Our slope, using any 2 points and going left to right, is up 1 over 1 with the slope of 1. And our equation is y equals x plus 2. For the rest of our function, the stepwise portion on the right, you notice that we have these closed sections on the left of each step and open sections on the right. Notice that this step occurs between 1 and 2, including the 1 but not including the 2. We then have another step that begins at 2, including the 2, and goes to 3. And a third one that starts at 3 and ends at 4, non-inclusive. The range values for these portions are 1, 2, and 3. The first step occurs at 1, second step at 2, third step at 3. Hopefully you'll recognize that this is just an example or a portion of the greatest integer function, and that this piece can be rewritten as the greatest integer function, which is the brackets around the x, if x is greater than or equal to 1. We can replace this whole section with the greater than or equal to 1 and the greatest integer function.